So I want to reiterate one more idea before we move on here. This is the idea that we said earlier that energy is always conserved. So the energy within the system cannot be created or destroyed. It can't increase or decrease, but it can be transferred. Energy can pass from one object to another, and energy can be transformed, which means it can change from one type to another. So energy is never created or destroyed, but it's only transferred between objects and transformed from one type to another. So think about a toaster. Let me give the toaster a little plug here. Your toaster is plugged into the wall. What's happening energetically with this process of heating up your toast? I know that you all asked this question this morning when you were making toast. You put toast in your toaster and you thought to yourselves, I wonder what sort of energetical process is happening. I hope Mr. Thurman tells me later today. Well, you're in luck. Thanks for asking. So we have electrical energy that is coming into the toaster, obviously, and the toaster gets hot. So we could say that electrical energy has been transformed into what type? Into thermal energy, right? So we have a transformation of energy. The toaster is a machine that transforms one type of energy into another. Most machines that you deal with do this. They transform energy from one type to another. Your laptop right now is transforming chemical energy in its battery into electrical energy, into light energy in the screen. We didn't talk about this, but sound is just particles of air wiggling around. And so that's a type of motion, that's a type of energy. So your laptop now is is transforming that electrical energy into sound energy and into thermal energy. Your laptop is probably getting hot, things like this. So electrical energy to thermal energy. The toaster is transforming that energy. It's also transferring energy. It's transferring that heat energy from the toaster into the bread, right? So if we were to measure all of the energy, none of it would be lost. It would all be accounted for. However, this is a big idea that I want you to be aware of that we will talk about more later. Is this a perfect process? No. Most machines, most things that take energy and transform them from one type to another or transfer them from one object to another, whenever you have energy changing hands from electrical to thermal, from the toaster to the toast, whenever you have energy being transferred and transformed like that, typically you have energy that gets lost, not energy that gets destroyed. Energy cannot be destroyed. I did not say it gets destroyed, I say it gets lost. It gets lost to the surroundings. Another way of saying that is that energy tends to spread out, or sometimes we use the word dissipate. It tends to kind of leave out to the surroundings, especially heat energy. Heat energy is very difficult to capture perfectly. It tends to get lost to the surroundings. So not only will the bread get hot, but the toaster will get hot, and then the toaster will heat up, and then the air surrounding the toaster will start to heat up. So that's what we mean when we say that energy dissipates out. It leaves the system and goes out to the surroundings. No process is 100% perfectly efficient. There's no way, unfortunately, for us to capture every bit of energy that comes in and put it right directly into the useful work that we want, into changing the bread into toast. We are going to lose some energy. Energy is going to spread out and dissipate to the surroundings, and again, typically as heat. So the toaster will get hot, the air gets hot. This is true of any process. Think about moving your muscles. If you move your muscles around, your body's going to heat up, and that heat will leave to the air around you. Your laptop is probably going to lose energy to heat, and that heat will leave to the air around you. So we tend to lose energy um, uh, as heat to the surroundings. It tends to spread out and dissipate. And once again, this does not mean that energy has been destroyed. I want you to look at this diagram. This is what we call an energy flow diagram. It shows how energy is flowing from type to type, from object to object, from the toaster to the toast, things like this. Example of an energy flow diagram that really drives all of life on Earth. If you've taken biology, you've probably learned about this. All life on Earth derives its, well, I won't say all, 99% of life on Earth derives its energy from the sun, from nuclear processes in the sun. Remember, I said earlier that nuclear fission is why the sun is able to create all of this heat and light energy. So we can say that nuclear energy is transformed into heat or thermal energy and light energy. And photosynthesis is the special process that has evolved on planet Earth to capture light energy, capture solar energy, and transform it into chemical energy. Plants are really, really good at taking sunlight and rearranging some chemicals, taking carbon dioxide from the air and water and rearranging all of those to store up chemical energy in the form of a chemical substance known as glucose, aka delicious, delicious sugar. So we've taken nuclear energy from the sun, uh, energy due to the process happening within the nuclei of atoms. That's been converted into light energy. That's been captured by plants and transformed into chemical energy. And then when animals eat the plant through a process known as respiration, they're able to transform that into different types of chemical energy. So from chemical to chemical. And then ultimately, every single animal that's alive does this. Um, that energy, some of it gets dissipated off as heat. So we say that we could have some thermal energy that dissipates. And you guys know that as a result of this process, animals breathe out carbon dioxide, release water, and that gets caught up in the cycle again. So this is really the flow of energy on planet Earth. Maybe I could add a little circle here because chemical energy is always kind of getting recycled and turned into different forms of chemical energy. The plants take it and turn it into glucose. Animals take it and turn it into a different type of chemical energy known as ATP. You guys don't need to know that. But chemical energy kind of getting run around this cycle, and energy will always get lost from that process because thermal energy will always dissipate. Your body has got to stay hot, and that heat will dissipate out into the surroundings. Does that mean that that energy is being destroyed? No, it's just leaving as a non-useful form. So this is the energy flow that powers all life on Earth. So these are the forms of energy, and we could even track the energy being transferred from object to object, from the sun to plants, from plants to animals, from animals to other animals, etc., etc. So big key idea: energy is conserved. It's never destroyed. It's never created. It's just transformed into different types and transferred from one object to another. It can be lost. It can dissipate out into the surroundings as heat energy. Heat energy is really hard to hold on to. It tends to spread out and flow away, but that does not mean that energy has been destroyed. That's not energy being destroyed. It's just energy kind of leaving and becoming less useful. One more energy flow diagram that I want to show you, which I think is just really kind of crazy to think about. But fossil fuels, fuels that power your car. In some places of America, these fuels power electrical power plants to generate electricity. So these are things like natural gas, petroleum, also known as oil, which ends up being gasoline in your car. Things like coal. Where did that energy come from? You guys know this is one of the kind of most valued um, forms of energy, sources of energy on the planet. One of the most controversial right now, as well, I suppose. But where did that energy ultimately come from? Well, it came from ancient plants. This is why we call it fossil fuels. A lot of people hear that term, they think it came from like dead dinosaurs or something, but that's not the case. It actually comes from ancient plants. So the sun here, millions of years ago, plants started evolving, and woody plants started showing up all over the earth. And at some point in the Earth's past, the Earth was covered in these forests. Um, and those plants were just performing photosynthesis, so taking energy from the sun, which is light energy, And you guys know, we could even add this detail, the sun uh, produces light energy as a byproduct of nuclear energy. And the plants take that energy, take that sunlight in, and they transform it into chemical energy. The plant dies and gets buried. It doesn't rot or decay. So what happens to that chemical energy? It kind of gets concentrated, gets packed down, gets fossilized and concentrated and almost purified. So the uh, the energy gets into a more concentrated form of chemical energy. And then over millions of years, we get a very concentrated form, which we now call a fossil fuel, like coal. So coal deposits all over the planet really came from what were once gigantic forests. Forests that failed to rot or decompose, their chemical energy just got buried and just sat and got more and more concentrated, and now we have coal. So coal contains a lot of chemical energy, and it's very easily burned. So the coal gets burned in a power plant, and that chemical energy gets transformed into heat energy. We're going to have a lot of energy being dissipated out here. So remember, wherever there's heat, energy is going to dissipate. So this is not a perfect process. We lose energy out to the surroundings. So energy dissipates off as heat. But then that heat energy, it's used to heat up water. So the water molecules start jostling, wiggling, bouncing around more. That's thermal energy. That's another word for heat energy. And gets turned into steam. That steam jet is used to power turbines. So it's used to rotate these big fans, basically. So that's kinetic energy. Um, and then that causes coils in a generator to turn, and through the interaction of magnets and electricity and this complicated stuff that we will actually talk about, that kinetic energy gets transformed into electrical energy, into moving electrons, and then that energy moves through wires and eventually goes to power your cell phone so you can play the stupid game you like to play on your cell phone. So it's all due to sunlight that got captured millions of years ago, and kind of almost through an evolutionary accident, the plants were not able to rot or decay, so they just got buried and got their chemical energy, which they got from the sun, which the sun got from the nuclear processes within it. Um, their chemical energy gets more and more concentrated. We get fossil fuels. Fossil fuels get burned easily. That's heat energy. Heat energy, the steam causes these turbines, these big giant fans to move, which is kinetic energy, and that turns parts of an electrical generator, which is another form of kinetic energy. And then finally, we get electrical energy. So um, the big idea here is that energy can be transformed from type to type, and it can be transferred from one object to another. Sometimes we get energy that dissipates as heat to the surroundings. We lose some. It doesn't get destroyed. We can still account for it. It's still there, but it's no longer useful to us. So this is I think, a pretty cool and kind of crazy example. If you think about it, this is absolute insanity. It's so bizarre. It sounds like a science fiction story that we're using ancient dead plants to power our technology today, to power our laptop screens. Like, what the heck is that? So I think that's pretty dang cool. So this is all due to the conservation of energy. That energy can be transformed from one type to another and transferred between objects. So thank you, conservation of energy. And remember, we're defining energy as um, the ability to change or causing a change, something like that. And we will study energy much, much more this unit.